But there was like
okay, so today we should finish chapter 6. So I don't have chapter 7 posted yet, but I'll get it posted today. Okay. So you can have that for Friday because we've got to keep going. Okay, so over the break, make sure you're doing homework and going over stuff because when we get back,
guns ablazing.
we're running to the end. Yeah. Okay. Chapter 7 isn't too bad. I think you'll find it. Okay, so the last thing we were talking about was this, and I want to know if you wanted to go from this compound to this one, what would you use for your reagents? Okay, so can you kind of come up with something?
Water.
Why would you use water?
That's what we used last time. Where are you gonna get the nitro from?
Okay, what is the difference between the starting material and the product? The bromine is gone, and what else?
nitrile.
The nitrile is there. So is there an OH there? So don't use one. It'll just get wet, FYI. All right, so what can we do? What do you want to do? What? Ammonia. That would put an NH2 there. So what do we want to put there? Come on. You're working. Don't be like that. What did you do to it, Taylor?
I think.
Okay. So the first difference is the bromine is gone and the cyanide is there. So what should be your nucleophile? What? Cyanide. Oh my gosh. Let's make sense. Okay. What else? A counterion. So you could write NaCN up there. Okay. Now, what can you tell me about the stereochemistry? What happened? What happened? Yeah, what is that called? Yeah, the sodium is just a spectator ion. Okay, so because it's inversion, what mechanism do we want? SN who? 2. Okay, so how can we ensure that we get an SN2 mechanism? I can write today. Why does that help? What do polar aprotic solvents do? They solvate the cation and not the anion. So what does that do to the anion? It makes it more reactive because it doesn't have solvent around it, okay? So name me a polar aprotic solvent. This is like a major clue, y'all, the polar aprotic solvent. You have to learn it. Name me one. I gave you 3. All I'm asking for is 1.
DMF.
Okay. So if you put this in DMF, it makes the cyanide ion even more reactive. So you are less likely to form a carbocation. Okay, so what kind of carbon is that one there? Primary, secondary, or tertiary? It's secondary. It's the one that's in between. If it's tertiary, you can't do SN2 on tertiary. If it's methyl and primary, it's really hard to do carbocation, SN1 mechanisms. If you're secondary, you're in between. Okay, so you want to have a strong nucleophile in a polar aprotic solvent to make it even more nucleophilic, and then you will get your inversion. Okay, if you just used NaCN in ethanol, for example, you'd probably start getting more of the R form because you would start getting inversion and retention because you get the carbocation mechanism. When you get the carbocation mechanism, you get both. Okay, there is no way to do the reaction this way and end up with an R at the end. Okay, like you can't, you can either get inversion or you can get it mixed, 50-50, racemate, okay? There's no way to start with one and end with the same. So R to R don't happen, okay? That's retention of configuration. Inversion is when it's flipped, retention is when it's the same. You can't get only retention, okay? Is that making sense? Y'all have me nervous. Okay, benzylic and allylic halide. So here's a benzylic halide. You'll see that the alkyl halide is on the carbon next to the benzene. Okay, here is allylic. Where did we see allylic stuff before? NBS, free radical, okay. This is an allylic halide. Okay, you can get either SN1 or SN2 depending on your conditions. Okay, the conditions for SN2 would involve a strong nucleophile and a polar aprotic solvent. Okay, like DMF, DMSO, or acetone. Okay, oh, acetonitrile, I gave you that one too. I gave you. Okay. If you put this in SN1 conditions, that would mean not a strong nucleophile. It doesn't mean it isn't a nucleophile, but if you're going to do something like solvolysis, where the solvent is the nucleophile, then that gives the molecule time to form a carbocation. Benzylic and allylic carbocations are super stable. Why? Because if you look at this carbocation here, it looks like it's primary, doesn't it? It just has one R group, but it's real stable. Why? What is the other thing that stabilizes? Resonance. So you can do resonance forms all around the ring. There's like a bunch of them. At least 3 probably. So these carbocations are stabilized by resonance. Okay, so depending on your conditions, that's going to alter which is going to be the mechanism that it forms by. Okay, down here, if you look at the allylic one, they actually showed you the resonance form. Okay, notice that this is the resonance right in here. Okay, notice on the first reaction they used methanol as their nucleophile, and what did we make? What was the new thing that was added to the compound? OCH3, not OH. Okay, the bottom one, OH, was added to the molecule because water was the nucleophile. These are both solvolysis. Solvolysis is where the solvent serves as the nucleophile. Okay. All right, did you write everything you needed to write? What did you need to write? The product? The whole thing? You didn't have it?
We had the
No,
products.
Oh, okay, okay. Okay, any questions on the products? These two up here, the ones that are SN2 are just nucleophile comes in and the leaving group leaves, one step. These down here, your nucleophile, you're forming carbocation, your nucleophile is adding, and then you're deprotonating. So these end up being 3 steps. Okay, because you have to do that deprotonation step. Don't ask me why that's there. Okay, I don't know, maybe I thought I couldn't write what I wrote on there. It wouldn't fit. Okay, vinylic and aryl halides. Okay, so vinylic is where the halogen is connected to the carbon of the double bond, and aryl is where the halogen is connected to the carbon of the benzene ring. Okay, those do not undergo either SN1 or SN2 reactions. Okay, they don't do either one. Okay, the nucleophile does not like to come in when there's pi electrons there like that. And vinyl and aryl cations are even more unstable than primary carbocations. The benzylic and the allylic ones were real as stable as tertiary because of resonance. But these are even more unstable because that carbon is already sp2 hybridized. Okay, it does not want to break the CX bond, whatever it is. Okay, so these don't react in SN2 or SN1 reactions. Do they do other things? Yes, they do, but this is not the time. Okay, amen. Okay, vinyl dihalides are when your halogens are on adjacent carbon. The Latin word vicinus means neighboring. I'm sure you're all Latin scholars. And if you're considered a geminal dihalide, if the halogens are on the same side, and geminus means twins. And is anybody the sign Gemini? Okay, Gemini is the twins. I don't know if that would help you remember that. Okay, so if I draw okay, is that vicinal or geminal? It wasn't a hard question. They're on adjacent carbons. All right. What about this one? Is it vicinal or geminal? Geminal means they're on the you don't have to be one of them, okay? All right, what if you're this one?
Okay.
That's geminal. What? I'm waking you up.
Us talking about stuff now. Who started it?
Okay, I think there's some questions where they're asking you to categorize them. Okay, these are just a regular dihalide. That's all that one is. Okay.
Don't do it yet. Okay, I'm good now.
Are you sure?
Do you know what your horoscope sign is?
Mine is Leo.
Oh, okay. Ooh, you're a lion. Okay.
All right. What is the structure of the organic product for the reaction below? Oh, products from the reaction below. Show a mechanism for their formation. You don't have that one? I did? What did I skip? Oh, okay. Don't worry about that. I think I just changed my order around a little. Okay, so what do we get? Okay, how do you approach it? What is the leaving group? Find that. The bromine. Okay, everybody agree? I'm going to write LG, leaving group. That's a G. No. I don't think the pen is sure. Okay, what's your nucleophile? It's the alcohol, right? The lone pair on the O. Okay, so what is going to end up replacing the bromine? Okay, so what do you want me to write?
What you had.
Yeah, what hasn't changed?
What didn't change, okay? Okay, oh, one more. Okay.
Put that. What are you talking about?
It was oh, okay.
I just wrote it together. Okay, so what do I need to do?
What you
That isn't it, is it?
No.
All right, so what do you want me to do?
put that other CH3 in there, I think.
Oh, no. So when did we?
I thought the O left.
Oh, you just want the product. You don't want the whole.
Well, we're going to do it in a minute. We have to talk about it a little bit first.
Oh, okay.
Yeah. First thing I asked was, what is the structure of the organic product or products from the reaction below? Well, I'm here to tell you that that is formed, but that is the minor product. Hang on. Okay, this is the major product. I will get out of the way. I will even give Caitlin time to write it down.
I'm a slow
Wow, so look at that. Tell me what happened. Besides, Dr. Watson went crazy.
They went
What swapped? The methyl and the alkyl OET thing swapped.
Is this legal?
Is this labeled? What do you mean?
Legal, because this does not look legal.
Oh yeah, it's legal. Okay, we're going to do the mechanism because the reason why it does that, the answer is in the mechanism. Okay? Okay, so what kind of mechanism do you think it is? You've only got two choices here.
SN2.
I feel like it's SN1.
It is SN1. And why did you feel that? What made you feel that?
I felt like Spence was wrong.
And that's a good reasoning, honestly.
That is not a good reason. Because you got to know how to decide, okay? What kind of nucleophile is this? Is it strong or weak? How do you decide?
I just know you have to go through, you have to deprotonate.
Yeah.
Right?
So that makes it.
It's strong nucleophiles have what charge on them? Negative. Does that have a negative? No. Is there some sort of metal thing in there? Okay, so we're going to do this mechanism. Okay, let's see if I have I do have a blank slide right there. All right, so here's where we're starting. I'll go ahead and put the H, just like I did on the other slide. You getting any faster at drawing your molecule?
No.
You get there. Okay, so what happens first? the bromine leaves. Okay, how do you draw the arrow? You're going to start with the electrons in that bond and push them to the, okay, so what do I have now? Draw what didn't change. Did we touch anything else on the molecule? No, so it's all still here. Okay, now let's evaluate what changed. We took those electrons and we put them on the bromine. So we have a Br with how many pairs of electrons? 4. Okay, so need anything else? Negative charge. Okay, my overall charge on the left is 0, so something's got to be positive on the right. What's positive? This little guy. What can you tell me about that carbocation? Anything? It's secondary. Okay, so we have a secondary carbocation. Is that the most stable carbocations that there is? What's the most stable? Tertiary. So what will happen is one of these methyls over here is going to move. It's going to move over here. Because what do you get after you do that? When it moves, it takes its electrons with it. So you now have, here's what didn't change. Okay, so when we move that methyl over, that methyl is now here. And what happened to that carbon over there? It lost the methyl and its electron, so it becomes, what kind of carbocation is that one? Which one's more stable? Tertiary. Okay, anytime you have a mechanism that has a carbocation formed in it, you can get what's called a rearrangement. The carbons will move, or a hydrogen will move, in order to help make a more stable carbocation. It will not do it unless it makes it more stable. Okay, if you lost your leaving group and you got a tertiary carbocation, it's probably not going to rearrange, okay, because it's already as stable as it can get, okay, unless there's something else in the molecule, but we're not there yet, okay? So now what do I do to get to that major product? Well, what was my nucleophile? It was good old ethanol, wasn't it? Don't drink too much of that over the break. Remember, you must be over 21, do some moderation, don't drink and drive. All right, so what do I do now? I go from my lone pair to the, where? To the what? The carbocation. Okay, I think it takes that route just like that too. All right, so what do I have now? Okay, that's what we didn't change. Now we made a bond from the carbon that was the carbocation to the oxygen. What's attached to the oxygen? Oh, CH2, CH3, and what else? And a hydrogen. Don't be losing stuff before you've drawn the arrows for losing stuff. Okay, what else do we need on that O? Are you positive? Yeah, I put the lone pair. Okay, now what do I got to do? What's the last piece of the puzzle? Yeah, take care of that charge. So here's my alcohol. It's going to grab a, oh, let me get black. It's going to grab the hydrogen. And what happens to the electrons in that bond? They go to the O and become the lone pair.
So could you have used bromine?
Yeah, you could have. But when you're doing solvolysis like this, there's going to be like a billion times more ethanol molecules in there than there is going to be halide ion. Okay, so what do you get now? You get CH3, CH, CH3. And then you get your C, CH3, CH3, O, CH2, CH3. And then, since I used the ethanol, you will also get this little O protonated ethanol. Okay? Which will have the bromide ion as its counter ion. Okay? Okay, how do you know if something's going to do this weird rearrangement thing? Well, you're going to have to, if you think it's SN1, you need to draw the structure of the first carbocation that would be formed. And look at it and say, if this moves, will it become more stable? If this moves, will it become more stable? Okay? If it can't get any more stable, then it won't rearrange. So I'm going to draw you some carbocations. You're going to tell me if you think they'll rearrange or not. Okay? So here is a carbocation. So I'm going to write rearrange. And this would be what you get if it does. We'll do it. Okay, so what do you think about that one? Okay, why no? Well, it's primary. And if you move to hydrogen, you'd still have a primary one. Okay? All right, how about this one? How about that one? What kind of carbocation is that one? Primary. Can it become more stable? Yes. Okay, what has to move in order for it to become more stable? One of the hydrogens. It's called a hydride shift because you're moving a hydrogen with its electrons. That's a hydride. Okay, when you move a methyl, it's called a methyl shift. Okay, so what do you get? This is yes. Okay, so what does the rearranged carbocation look like? Okay, I've got CH3, CH, CH3, and a plus. And what kind is it? Okay. If you have this carbocation, will that one rearrange? Okay, what kind is this one? Secondary. Okay, what is going to move? Which hydrogen? This one, yes, because if this moves, you'll end up with a tertiary. What if a hydrogen moved from the left one? From the left carbon, there's 3 over there. You would get a what kind of carbocation? Primary. Is that more stable? No, so it won't do it. It only does this to become more stable. So this one's a yes. Okay, so what does it look like? So I'm going to draw my hydrogen down there. You could just write a CH2, but I want you to make sure that you get it. Okay, a couple of things. When you draw the arrow to show that something is moving, okay, you always go from the bond to the carbocation carbon, okay? Notice that these carbons, like this one and this one, oh, my bad, this one, are becoming positive. We don't draw an arrow that the plus is moving around. It's just like when we did resonance forms. You draw a resonance form and the carbon becomes positive, but the pluses aren't hopping. There aren't protons hopping around, okay? Well, it's kind of, sometimes it looks that way, but that isn't really what's happening, okay? Okay, carbocations can rearrange. Is this the slide? Yeah, okay, I thought it might be. They rearrange to make a carbocation that is more stable. The most common migrating groups are H- and a methyl minus. You can move some other things, as you'll see over the course of the rest of the year. Okay, so what would be the products for the reaction that's up here, and what would be the major one? Oh, I didn't get my work thing. All right, if the thing pops up and says that I'm low on power, somebody yell at me. So I can go run and get my thing. What?
It pops up this time. It didn't pop up last time.
It didn't?
Yeah, it did. We just didn't think. I didn't even see it.
You're like me. Just, that wasn't the focus, right? Yeah. Okay, so what are the products? So in other words, draw the first carbocation.
It is. That white one power cord?
Yeah, but
It
look,
doesn't read.
look, y'all. It don't reach. I have to get an extension cord. Hmm? You think I should move my laptop?
Oh, no, I don't care.
I'm worried about like dropping it. If this thing
You don't
messes
run
up-
over it. I think
If this messes up, I might cry. You're telling me. All right, so
like your sweater.
so while thank you. So while I do this, y'all are figuring it out, right?
Yeah. It's drawn.
How do you know that that's going to be an SN1 reaction?
Okay, that's a good question. How do you know that it's going to be an SN1 reaction? Give me some reasons.
Because it's a carbocation rearrangement.
Does that have a negative charge? No.
So that's always going to be true. Okay.
If you're secondary or tertiary, you're going to be SN1. Remember, no SN2 on tertiary centers. Okay. Okay, so how are you going to figure out your products? What is the first carbocation that's formed? That's what I did, Allylic. So draw that little structure first. You don't have to write out the whole mechanism to get to the product. You just have to do a little piece of it. Okay, do you see how we get that carbocation from that? Here, look, we could draw it. Look at that. Okay, so what would it rearrange to? It's a secondary carbocation. How can it become more stable? What's got to move?
The hydrogen.
The hydrogen, which one?
On the tertiary.
Yes. Here, I'll draw it in like this. Okay, so we go from secondary to tertiary. Okay, so I'm going to draw that piece of the mechanism in here. So let me fix it. So okay, so how would you draw your arrow? You go from this bond over to the carbon that's positive. It takes those electrons with it so that the carbon that's left behind becomes positive. Okay, now what was your nucleophile? Just because it's not negatively charged doesn't mean it's not a nucleophile. It's just not a super strong one. So what are we going to do? Yeah, your ethanol. Okay, so what is going to be the major product? Uh-huh. Okay, and what's on here? Yes. Exactly. Okay, I want you all to make a note. It's not OH. Okay? Because that CO bond there in that alcohol is covalent. Okay? The nucleophile will add and then you'll deprotonate. That's how you get the OET on there. Okay? Sometimes you'll see this as a shorthand for an OET with an ethyl. Okay? You might see OME also for when it's an O methyl. Okay? How do you feel about that? You got, the key is to remember to look for them. Okay? That's the key. Okay, so what about this one?
Yeah, we did.
No, it's different, y'all.
Oh, did we do that one?
No, it's different.
It's different, isn't it?
It is.
It is. You got to be careful. Yeah. Oh, it's okay. All right, so what are we going to do? What happens first?
Not really.
Who leaves? Okay. All right, so I'm going to draw what didn't change. How are you doing on that? On drawing what didn't change? Are you good at that? Good. Okay, so now what did I get? Here, I'll make what changed be purple. What am I going to have? My bromine is going to have what? 4 pairs, which makes it what charge? Okay, and then what else do I need? Where? Yes. Okay. I'll even put a circle around it because I do that sometimes. It doesn't matter if you put a circle. I had a teacher one time for one class that got on to us all about putting circles around our churches. He was the only one, and it wasn't worth it. You'd make a big deal out of it. It's just kind of dippy. Okay, then what's going to happen? What kind of carbocation is that one? What? It's primary. Just because I drew out all the bonds doesn't make it tertiary. Carbons make it tertiary. All right, so can I make it more stable? What do you want me to move? Okay, the H on the charge?
Just like flip it.
Here?
That one. That one.
Okay. Okay, that's going to go there. There we go. Okay, so what do we have? I'm going to draw what didn't change. I didn't move those methyls, did I? Okay, I moved that H over here. This is what I changed. Okay, what happened to the carbon the H was on? It becomes positive. Are you positive? Okay, then what happens? That's your clue. What is that going to do? Go where? Okay. Okay, that's where I was. Now I have a bond to the O. Okay, and what else is on that O? CH2CH3. And what else? That hydrogen. Okay, what else does that O need? Okay, now what do we got to do? Get rid of the hydrogen. Excellent. So we're going to take another ethanol. And what is it going to do? Going to grab the H, the proton, and then these electrons go to the O. Follow through, follow through. If you don't follow through on the shot, it doesn't go in the hoop, right? Okay. If you don't follow through and you swing the bat, you bunt, right? Sacrifice. Was that what that's? Okay. I don't know. All right. So what's my product?
Did you play sports in high school? Or
No. Are you kidding? No, my daughters did. Are you kidding? Like one day in gym class, I caught 2 fly balls, and it was the talk of the school. Louisa caught 2 fly balls. Did you hear? Like, I heard it all day. It was hilarious. And we played in Chicago area 16-inch softball with like balls as big. Like, I never put on a mitt until I met my husband, and he said, "Oh, do you have a mitt? I have a mitt." I'm like, "No, why would I have a mitt?" So he had to go get me a mitt, seriously, and teach me how to play catch. Okay. All right. So what have we got? She does. Okay. What happened to this? What did this give us?
I just think she's tired of writing out.
Okay, now why do you think this is the only product formed?
Hey, can you do that?
What? Keep on doing what?
You can't draw that cross like that.
Can't?
Why not?
That's not a chiral center.
It doesn't matter. It's not a Fisher projection.
Since when?
Since now.
There, I'll put this in.
Very
Sometimes,
I understood.
I mean, you could have drawn it like this.
Okay, yeah, that's fine.
How's that? T-butyls are kind of weird. Okay. Do you have any other problems that I need to know about? Relating
I
to
mean,
this?
nothing that relates to organic.
Okay, okay. Oh, look at that. I left myself all that room. All right, so here's a comparison between SN2 and SN1 reaction. SN2 is typically a one-step mechanism. And SN2, it says it's a stepwise mechanism that goes through a carbocation intermediate. Remember, the 2 and the 1 do not mean how many steps, okay? They mean how many molecules are present in the rate determining step. Okay? We got it? Write that down like 50 times if you still don't got it. Okay, so in SN2, the rate determining step is bimolecular, meaning how many molecules? And the SN1 is unimolecular, meaning how many molecules? One. What is the rate determining step in an SN1 reaction? Forming the carbocation, okay? In an SN2 reaction, because no carbocation forms, there are no rearrangements. So no rearrangements. In an SN1 reaction, you have to look and see. Maybe you make a tertiary carbocation to begin with and nothing rearranges. Okay, I mean, it doesn't have to rearrange. Don't try to force it, look at the structures, okay? Now, stereochemistry. SN2 is inverted. SN1, you get both because your intermediate is flat and the nucleophile can come in from either side, okay? Notice the reactivity order for your alkyl halide. This is for the RX. In case that's not clear. Notice it goes methyl, then primary, then secondary, then tertiary. No SN2 on tertiary centers. Okay. Notice the SN1, tertiary, then secondary, then primary, then methyl. This parallels carbocation stability. Carbocation stability. Okay, that makes sense. Okay, this shows the different kinds of alkyl halides. Methyl and primary are pretty much going to be SN2 only, okay? Vinylic and Aryl are neither, so that makes that easy. Okay, tertiary are SN1 only because there's no SN2 on tertiary centers, okay? Okay, now when you get into these, this primary and secondary benzylic and allylic, it's going to depend on conditions. Same thing with secondary alkyl halides. It's going to depend on conditions. Tertiary benzylic and allylic will be SN1 only because no SN2 on tertiary centers, no matter what kind of tertiary. Okay. All right. Now we have to get a question in, and I know that I have one. Honest. Here we, oh no. Here we go. Okay. I'll go back to that other slide. That was a good slide. All right. So predict the major organic product for the reaction below and the mechanism by which it was formed. Okay. I can't even sit down on my stool because I'm afraid I'm going to knock my building if I try to step over. So I'll do that. That little thing up there is still
Okay. Okay, I haven't read it.
okay, so think through all the things here. Oh, how many of you are there? 17? 21? We need 3 more. All right, make a guess so that I can explain it before you go.
What is happening? Yeah.
Did you make a guess, Caitlin?
Yeah. I guessed a long time ago.
Oh, good.
I know it.
You know it? I'm excited. Look at that.
Not what happened.
It's kind of, well, how do you know? Okay, I'm quite proud that no one picked A. I'm just going to tell you. Why am I proud that no one picked A? Because what are you going to put on the molecule in place of the bromine? An OCH3, not an OH. Okay. Okay, so if it is an SN2 mechanism, you should get what product? Should it be retained, inverted. What's a stereochem? If you get SN2, you always get inversion, okay? If you get SN1, you always get both. So which one is out? C is out. Okay, so is it B or D? How do you decide? Look at your nucleophile. Is it negatively charged or neutral? It's what? It's neutral. So which one is it?
Whoa.
Yeah.
Dang it, I keep getting those mixed up.
Okay, well, write it down so you learn it. Okay, we will start chapter 7 on Friday. All right, let's see if I can get out of there.
Well, I selected everything.
Yeah, 'cause it's,
Sorry, go ahead.
the same thing. Rich, yeah. It just has to do with
You gonna tell me that? What? Oh, are you balling?
Dr. Wilson, I won't be here on Friday because we have an away game.
Oh, okay. Well, hopefully this will work. Look it up and
Okay.
watch it over the holiday.
Okay, thank you.
Have that talk left?
Hey, will you be here? Like,
How did that go?
well,
Today?
after 1? Yeah.
Yeah.
Okay. I have like a question about calculations because we have to like take this lab final today,
Oh,
and I wanted to ask you about
okay.
like theoretic like percent recovery and then percent yield.
Okay.
How to
Okay.
calculate those,
Okay.
just so I make sure. But I have class at 1 or like right now, so I'll be back after 1.
Okay. Okay.
Thanks.